Hey everybody, my name is Madeline Ackery and I am the Energy Storage Manager here at Soligent. And we're really excited to have SimpliPhi here. We really love SimpliPhi. Their products are very high quality. The partners that they work with are really well integrated with their product. So we're really excited to talk to you guys about the features that their batteries have, specifically related to the charging, discharging, and state of charge, which understanding these different elements of a battery is really valuable for understanding the health and the longevity of your battery. So this is a really valuable session to learn more about how to keep your battery in good health. So let's have Troy Daniels take it away from SimpliPhi. We're so happy to have you here.
Awesome. Thank you, Madeline. Hi, everybody. My name's Troy Daniels. I'm sure some might have already sat through a few webinars with me in the past. Technical trainer here at SimpliPhi Power. As Madeline said, so yeah, we're going to go through, this one's a bit more targeted. We're going to talk a little bit about just understanding the battery's characteristics and really what it can mean as an installer and really how it can benefit you, not just as an installer, but as a customer as well. And really just looking at, how this plays into use cases and really just overall experience. I've added a little extra to this presentation. So we are going to go into some sales stuff as well. So if you're interested in, looking at picking the right product for your projects based on our various product offerings, as well as even some financing stuff. So with that, I'll just go ahead and kick us right off. There we go. So company history, I always am remiss if I don't start at least with these kind of standard opening slides. So apologies if you've sat through it before. For those that have not, we started as OES Energy in 2010. That was actually the original name of the company. What we were really looking to do at the time was figure out a way to come up with a solution to a problem that we saw. The problem that we were seeing was failing lead acid batteries in the field, as well as unsafe lithium chemistries being used to try to replace these lead acids. And the kind of idea was, how can we make a safe battery that also utilizes lithium and fits the need of these replacements? And really what we found was if we use lithium iron phosphate, which we'll talk about here in a second, we were able to overcome the challenges of other lithium batteries while still being able to replace standard batteries. In 2011, 2012, we actually had a chance to work with the Department of Defense. This was one of our biggest jumping off projects as a smaller company, where we were able to prove that our lithium iron phosphate batteries would be successful in the field and did not pose risk of danger, which when I say danger, typically I'm talking about thermal runaway, which is what you see in other types of lithium chemistries. Thinking like a Tesla or anything cobalt based, that's where that inherent danger comes from, is the cobalt in the lithium, which is prone to thermal runaway. At the time, the Department of Defense said no batteries whatsoever, no lithium batteries whatsoever. They were too dangerous. They let us have an exception, and happy to say that they had no failures or no issues with thermal runaway or anything like that. So from there, we continued to expand our product lines, actually relaunched as SimpliPhi Power. And really, since, this has been over a decade now, and since then, we've continued just to ramp up manufacturing, our product line. We've added new products to our line. We continue to grow the current products we have. And the manufacturing, as I mentioned, that's a big one. So we continue to manufacture here in the United States, in California, and we outgrow very quickly. So we've built moved to a bigger facility. I guess it's not that recent anymore. It feels like it is, but it was quite some time ago now. And we continue to expand that facility with just more capacity to build more batteries, get more batteries out to our distributors, keep stock high. So again, lithium iron phosphate is kind of the cornerstone of what we do. And if you're curious, so if you're looking at the internals of the battery, you're looking at a cylindrical cell with a lithium iron phosphate chemistry. This is kind of the the building block of all of our products. Some kind of things that we try to address as a company in general: escalating energy costs. I think if you're, these are some big ones. If you're looking at selling batteries to homeowners, to whatever the customer might be, oftentimes I find that they fall into one of these three categories, or maybe all three, or maybe two of three. Escalating energy costs being probably the biggest. U.S. residential electricity prices rose 15% in the last 10 years. I mean, this trend's not going anywhere. It's going to continue to grow as far as I'm concerned. I can't see any reason why this would go down as far as the utility companies actually charging less. They're going to continue to charge either more or about the same. And really, this all ties into, again, with failing infrastructure too. So looking at 2010 through 2019, marked actually the costliest decade on record, with economic damages due to severe weather reaching 2.98 trillion globally. We've seen a lot of this lately, things like what we saw in Texas and other areas. If you're in California and you're dealing with PSPS shutoffs, or even actual shutdowns that are not planned. So failing infrastructure is becoming pretty big thing when it comes to why a customer might want to add a battery system. The U.S. electrical grid is aging, and we got to look at ways that we can add to that. My kind of key word I always use is looking at distributed assets as a really easy tool to boost the infrastructure, and really selling that to a customer as, they, by even just adding a battery to a system, like a home system, maybe a solar system, they've added their own distributed assets. So not only are they ensuring their own energy security as far as cost and power when the grid goes down, but they're also building on the existing infrastructure with distributed assets. And of course, decarbonization, looking towards the future, and renewable clean energy. Okay, so very briefly, I'll just go through some kind of standard products before we jump into the kind of base material on this one. Our biggest seller still is the Phi 3.8. This is our standard Phi battery. I'm going to mention this. It does have the black case here. This is going to be a white case pretty soon. It's kind of in limbo right now as it switches over. Same exact battery though. It's a 3.8 still. It comes in 24 and 48 volts. These are parallel connections only, so you don't want to put two of these in series. They come with an integrated battery management system. This one is just internal, meaning it doesn't communicate with the various other components in the system. We will talk about a battery that does do that. And it does have an integrated circuit breaker, which I think is really convenient for installation and protection. So again, this is still our biggest battery. They're scalable and modular, which is really the big one. You can scale these up. There's no limit to how many you can put into parallel, technically. We offer some smaller products as well, like our 12 volt, 24 volt, and the 1.4. This is also scalable, small and lightweight, about 33 pounds. I find it to be great for mobile applications. It's actually compatible with most standard charge controllers and inverters that we would use on any of our other, maybe let's say 48 volt or 24 volt products that are larger. Still has an integrated battery management system, and you can actually get it with this Anderson connector or even bare wire, which if you're looking at mobile applications, makes a lot of sense not to have exposed terminals. So that can really be a helpful tool. Our access line, I won't dive too deep into it. If you're really interested in learning more about the access, I'd say take Battery 101 that we have up, where we dive into each different variant, but we do have two variants of the access, the one with the Solarc and the one with the Schneider. These are plug and play, all-in-one DC or AC coupled units. Could be used for new, existing, on-grid, off-grid. They're NEMA 3R rated cabinets. So again, we're talking batteries, the charger, and the inverter all kind of put into one. And it's in this NEMA 3R enclosure, so you can stick it right outside. Okay, and our newest addition to our SimpliPhi product line is the Amplify battery. Looking at the specs kind of up front, looks very similar. Still a 3.8, only comes in 48 volt. UL certifications are the same. Max discharge is a little bit higher. So at 10 minutes, it can actually do 100 amps DC per battery. So it does come with a little bit of a larger breaker. It actually has the same dimensions and just about the same weight. It's a little heavier at 86 pounds. The good news is, though, is if you are using existing wall brackets or our existing cabinets, this new battery does fit into those. The big difference with this battery is that it actually has closed loop communication. So the BMS does have the ability to communicate with the inverter. Currently, that is just with the Solarc. We are just kind of wrapping up a few other inverter manufacturers that we're going to be pairing with as well. Solarc was the first one we came out with. So you can actually connect to the Solarc through the battery management system, perform some pretty advanced functions like auto-populated set points, high-level protection, high-level state of charge readings, voltage, charge, and discharge, and even flexible sizing. So if you're familiar with our sizing, we typically have a pretty strict rule when it comes to Phi batteries, the standard ones, where we want 2-to-1 ratio, meaning if you've got an 8 kilowatt inverter, you want 16 kilowatt hours minimal of battery. In this case, you do not have that requirement, as the battery has its own protection built in to make sure that it's not over discharged, even if the inverter is too large. A little note on the side here, it is limited currently to 40 batteries in parallel when it comes to the Amplify battery. All right, so that's products. So now we're going to jump kind of through charging characteristics. We'll talk about charging as it relates to voltage, as it relates to amperage. Then we'll talk about discharging in the same kind of manner, and wrap up with some general SOC stuff before going into these a few sales slides. Okay, so when it comes to charging, C over 2 is kind of the name of the game. C over 2 not just being how we rate our battery's amp hour capacity, but the max charge of the battery in this case. So if we're looking at these figures kind of straightforward, the 3.8 48 volt, you can see has 37.5 amps DC at 48 volts. That's its C over 2. That's its max charge rating. The 24 volt, 75 amps DC at 24 volts, and so on and so on. So you can see, you know, these are related to C over 2, or maybe just a little bit less than C over 2 if you're talking about the 12 volt and the 24 volt stuff. This is per battery. So you add, 4 batteries, then you multiply 37.5 times 4, and that gives you your max charge rate of those 4 batteries. We give it in DC. If you look at our spec sheet, you'll see it in kilowatts as well. Try to make it as easy as possible. So, it's all about conversion, though. At that point, it's all the same. But DC is kind of the easiest way to give it if you're looking at charging from a DC source. Amplify does have a similar charge current, so it has that 37.5 that you'll see here on this 48 volt battery. However, when it comes to Amplify, you don't really need to worry about the charge current as an installer, because if you're hooking up to the Solarc or the next few inverters that we get hooked up with that closed loop communication, it auto-populates that set point. So it knows, hey, I have 4 batteries in the system. This is my max charge rate. So you don't have to do that kind of more in detail math when you're programming things. It does it all for you. It's important to keep multiple charging sources running at once in mind when you're thinking about this. So if you've got like a wind turbine and a solar array and a generator, just keep that in mind. Make sure that their priorities are set so they don't run at the same time. And if they do, that their charge limit still matches the battery's max charge. Global charge is definitely a thing. If you're looking at like Outback's my big example when it comes to global charge, where they actually have that setting where you can say, entire systems max charge rate is X, and it won't allow no matter what source comes on, it'll keep that in mind. So again, battery protection. So there is a BMS built into the standard Phi battery, but it's really important that all programming is done properly. as that BMS has its limits. It's if you push it too hard over and over, you can still hurt the battery. It's not gonna keep disconnecting if you're pushing it, double beyond its charge limit. Eventually, you will hurt the battery. The SimpliPhi, as I mentioned, though, does have the ability, if you're hooked up to an inverter it talks with, to ensure that the charge rate is never higher than what it wants, regardless of how you program it. So if we're talking about actually programming and limiting charge rate on various devices, charge controller being kind of my first go-to, very easy. You just, again, let's say that we have 3 of our 48 volt, 3.8 kilowatt hour batteries. So we know that we would multiply this number times 3, so 112.5 amps DC. That's our max charge rate. Let's say we had 2 FM80 charge controllers. You would just make sure that you limit that to match that 112. And the charge controllers are really easy to program in that sense, and just type that value in. The inverter charger, so if we're talking about charging from an AC source, it's very similar, really easy. All you're doing is putting that value in and making sure that it's set correctly based on the quantity of batteries. And again, I'll probably repeat this too many times, but the SimpliPhi itself does that auto-populated set point on its own. It will limit the charger. When you're hooked up to the Solarc, for instance, it'll limit the charge controller if you have DC coupled, or it'll limit the inverter charger if you're AC coupled, or both. AC coupled systems are actually important to think about when it comes to charging limits. So unlike a charge controller or an inverter charger, which we are using the inverter charger when we're AC coupling, we can't really rely on that set point when AC coupled. So let's say you've got an 8,000 watt array and your batteries can only handle, let's say your battery bank can only handle 6,000 watts of charging capacity. You can set the limit on the inverter to say, hey, don't charge too much. But when the grid goes down, it starts AC coupling. I've seen it happen a lot where it dumps the entire array in before it can actually start to limit the PV, and you might end up with a damaged battery. So it's just important when AC coupling, just follow the 2-to-1 ratio again. So if you've got 8 kilowatts of PV, just make sure you have 16 kilowatt hours of battery. Make sure that that battery bank can handle the entire array if for any reason it was to discharge into the battery. And that's all outlined if you're looking at our guides. I think section 3.1.1 has a really good section regarding, and that's in our access manual. It's a good place to find where it talks about PV limits when AC coupling. It's also important to think the inverter also typically has their own limits as well. So if you match the inverter limit and your battery size correctly, everything should work out fairly easily. Okay, let's talk about charging as it relates to voltage now. Pretty straightforward when it comes to this. We're talking about, let's say, charge controllers. Charge controllers are a little different maybe than an inverter charger when it comes to voltage, and really just charging set points. We do use absorb, bulk, and float. You don't need to use float, but we can use it when it comes to a charge controller. Honestly, it makes sense. Let's say if you're, maybe working off a PV array, you want to utilize as much sun as possible. You can use that float voltage. So absorbent bulk are always going to be the same voltage, 56.0. You might see it in a few integration guides, just a little bit higher or a little bit lower. That's just based on the equipment. Some equipment just has different variants that we have to work with. But 56 is the most ideal at 6 minutes. 6 minutes is the absorbed time. However, you'll often see people utilize things like end amps or return amps. And that's just the amount of current that needs to be present that it's tapered off to before the charger disconnects. That can be found in our manual too, but if you're looking for that value, it's really easy. It's just 2% of the battery bank's entire capacity. So again, float charge, we really only use on a charge controller. If we're using an AC source like the grid or a generator, so through the inverter charger, I typically would not recommend using a float charge. You're going to waste a lot of money in gas or electricity. Float typically sits around 54.0 volts. Now, I'm sure everyone's noticing at this point, I'm speaking almost entirely in 48 volts a lot of the time when it comes to this stuff. It's just easier for the presentation, so we don't have to jump through a million hoops going through 12 and 24. But simple as it is, anything related to voltage, just divide it. So if it's 24 volts, just take 56, divide it in half. Very simple. Current's a little different. That's kind of why we extrapolate a little bit more on the actual current ratings when it comes to different voltages. Okay, so a little bit more regarding voltage and charge controllers as well is think about using your high rebulk or recharge. So if you're familiar with charge controllers, this is the setting that actually triggers that cycle. If you're using a charge controller, it's hooked up to something like a solar array, you can set that rebulk fairly high. I try to set it always under 52.0 volts, and we'll talk about why that is later when we go into state of charge. But you can set that pretty high so that you're always triggering a charge cycle and hopefully going into the night with a really nice full charged battery. So inverters, again, the voltage set point's basically the same, 56 volts at 6 minutes. The big difference is I don't recommend a float charge when it comes to an inverter charger. So if it's an AC source, so again, generator, grid are the big two I think of. A little bit regarding, it's kind of out of place here, but a little bit that I like to always mention regarding inverter compatibility that always comes up regarding voltage set points. The charging is always important, but most important when it comes to inverter compatibility on our batteries, what is the low battery cutout able to reach? 48.0 on our 48 volt batteries is the lowest that we ever want the charge control or the inverter low battery cutout to ever be programmed to. You can see damage if you go below that point. So if your inverter doesn't go up that high, I would say it does not work with our battery. So we don't necessarily have like a big approved list of inverters and chargers. It's just more dependent on, can it hit the parameters that we're asking? Do they warranty lithium batteries? You'll see an approved charger list on our website. This is actually related to standalone chargers. So something you might plug into the wall to bring a battery up, like a bike charger. So that's different actually. Okay, so now I'm going to jump kind of into discharging. So we're going to go through discharge the same kind of way we just went through charge, where we're going to talk about current ratings and how it relates to amperage, and then go into voltage. This is a bit of an older chart, but it's still, I still like to look at it here. You can kind of see it's a really good example of, and we'll get into this in the SOC portion, but you can see the voltage really high here and then drops really fast. That's what we call resting state of charge. Again, we'll talk about that, but then you can see the voltage curve is nice and flat as these batteries discharge. Very easy to remember the discharge settings when we're talking at least about max continuous discharge. So not max discharge at 10 minutes. We're talking about the continuous. They're the exact same as the charging. It's still that C over 2. So all of these are still the same. You can look at the charge and discharge is the exact same as far as per battery. So that 37.5, if we're looking at the 48 volt, it's the same thing for charge and discharge per battery. Again, the SimpliPhi does all those calculations for you. And if you're hooked up to the Solarc, it can even limit its own discharge and make sure that you never over discharge the battery, even if you have an oversized inverter. Most inverters, unfortunately, don't have the ability to limit discharge. Like if you're looking at, like, let's say you put 2 Schneiders and 2 XW Pros, and you've got 4 batteries on those 2 inverters. Well, if the inverter calls for that much, let's say 12 kilowatts of power, it's going to call for it. There's no way to necessarily, there's a few kind of newer stuff coming out where you can program it, but it's pretty tricky and it's still not kind of foolproof yet. So just size correctly if you're using our standard Phi batteries, that 2-to-1 ratio. The SimpliPhi, again, though, doesn't need that if it's hooked up to the Solarc. You could have 1 SimpliPhi battery and not even have to worry about this max discharge. It can be hooked up to a 12 kilowatt Solarc and it will not over discharge. Surge is a bit different. So when it comes to max discharge, we can talk about the rating at 10 minutes as well. So just some quick numbers here for the 3.8. It's actually 80 amps at 10 minutes for both the 48 and the 24 volts. So what does that mean for the 24 volts? It means it actually has a lower surge rating compared to a 48-volt battery. So if you have really, I always recommend if you've got big loads like air conditioner, heat pumps, things like that, 48 volts tends to be the way to go either way. 60 amps DC at 10 minutes for the smaller 1.4 kilowatt hour battery. Again, 12 and 24. So as we go down in voltage, we actually have a little bit less surge. And the SimpliPhi actually comes in at the highest surge rating, 100 amps DC at 10 minutes at 48 volts per SimpliPhi battery. So it can handle quite a bit for 10 minutes. This will cover any bigger, pumps and things like that that might come on as long as you're sized correctly. A little bit regarding C/2 in general and just these numbers. Residential use is something to think about. Let's talk grid tied battery backup. Most of your customers are not looking to discharge their batteries in 2 hours. So really, if you're sizing correctly for your customers' needs, you're probably not even going to scratch the surface as far as needing that C/2 discharge. C/2 charge, yeah, that's great. It's a great feature to have. You can get that battery charged up nice and fast when sun's available, when the grid's available, when whatever's available. But as far as like real customers using these batteries, there really shouldn't be too many reasons where they need that 2-hour discharge. They should probably have more. Most customers are going to ask for more backup than just 2 hours. Off grid, same thing. You're going to need to cover your entire home throughout the day. So these C/2 limits shouldn't even make too much of a difference when sizing. You should be well sized over that C/2 limit because you should be able to have the customer's expectations met as far as how long they want that battery to last. I've seen people use output inline breakers for protection to kind of make up for not sizing correctly on the inverter to battery ratio. I wouldn't say that's foolproof by any means. It can help. You can put it in line with the battery bank or on the AC output. So let's say, you've got your battery can only handle 37.5 amps DC of discharge and your inverter puts a little bit more than that out. I've seen people put a 30 amp breaker in line. But again, you're relying on that piece of component. So if something fails, that does go against our sizing guidelines. So it's just sizing correctly is the easiest way to avoid over discharge. There's something called the knee, and that's just my phrase, and you might hear it, you might hear it a few other places as well, I guess, but this is really what I call it is the knee. And this refers to this kind of when you're at this low state of charge, where the battery really starts to discharge a little bit faster, and that discharge curve kind of gets a little bit steeper. And why is this important to kind of understand? Well, it can actually affect your low battery cutout. So let's say that you've got your low battery cutout set for 48.0, and you've got a really heavy load, maybe a C/2 load as you start to approach this point right here. Well, if your low battery cutout can't catch the system in time, your battery might go into its own internal low battery cutout before the inverter has the chance to do this. So avoiding the knee is kind of important so your customer and you don't have to end up going on site and actually doing a manual reset of the batteries. Easy ways to avoid this: set the low battery cutout at 80% depth of discharge, 50.2. That should be plenty of time for it to catch it, even if there is a pretty heavy load. Avoid heavy loads as it gets down to this low state of charge. Have things like generators run if they need to pick up the pieces. So just to avoid that low battery cutout function in general. There's hysteresis settings and low battery cutout delay times that are typically programmable. So you can make those a little bit more sensitive. Again, I know this is kind of confusing, but the idea is that we want the inverter's low battery cutout to disconnect and not the battery's internal disconnect. The battery's internal is there as a last resort. And once it disconnects, you actually have to go and get on site and reset the batteries, sometimes even charge the batteries. So we want the low battery cutout to function correctly. Okay, so now just kind of to wrap up this section, we're going to talk about state of charge. Um, and really, when I look at state of charge, I think it's most important to look at what is resting state of charge. This question comes up a whole lot. Actually, we had, I think, 2 inquiries just yesterday looking through the tech inbox of people not necessarily understanding the difference between charge voltage and resting state of charge. So while we charge at 56 volts on these batteries, that by no means is the 100% state of charge of the battery. It's much lower than that. And once that battery disconnects from the charger, there's a small load on it. That is what we consider resting state of charge. And that's really where you can measure that 100%. This is a controlled environment. I'll be honest here. This is by engineering, and this is probably not as accurate as what I would expect to see in the field. So 52.5 or higher is considered 100% state of charge. Again, that's at resting SOC. I've seen in the field really more like 53, 53.3. But voltage correlates with SOC, and it's fairly easy to kind of get a rough estimate just based on, voltage versus the state of charge. As far as battery monitoring and state of charge based inverters go, if you're looking at like something like the Schneider or even the Outback and you're setting up your battery monitor, they're not perfect when it comes to lithium batteries still, or at least ours from what we see. We do have integration guides that walk you through the specific set points, which are pretty precise to make it as accurate as possible. But really, it can be tough to get a really accurate state of reading, as a lot of these battery monitors are still based around lead acid a little bit. I would recommend, looking at, if you really want some high level accurate readings, the SimpliPhi battery, our newest battery, does report its own state of charge directly from the battery. That's going to be the most accurate state of charge reading. So why is this important? Why would you want to know any of this stuff? And really, why would you want to know this as well? Well, the point is that you can now, with this kind of knowledge of state of charge, understanding the battery's characteristics, you can use some more advanced programming and understand what your customer wants as a mode of operation and how to accomplish that. Maybe they want their generator to turn on a certain percentage. Now you understand the correlation there. You understand when to set it. You understand how to avoid things like that dropout on the knee. Your recharge volts, you might understand a little bit better as far as how high you can go with that, and why maybe the charge controller versus the inverter might have a higher rebulk. It really all just kind of comes back down to customer preference and being able to kind of go outside of the norm of our standard settings and understand how to manipulate these settings in order to give your customer kind of the best experience possible. A big one I always see that people use is understanding cell voltage. By understanding the maximum, so like if you understand that 53.3, let's say, is 100% state of charge, then you understand that you can sell about down to that point on cell voltage before you're selling the battery to sell off excess PV. So again, it all kind of benefits not just the installer in these cases, but it benefits the customer as well to have an installer that understands the characteristics of these batteries and can kind of mess around with set points and characteristics as they see fit for the mode of operation. Okay, so I've added a few slides in here. These are just kind of related to selling SimpliPhi. So I'm going to jump through these really quick before I wrap it up regarding our IQ program, and we can go into Q&A. So selling SimpliPhi, I know as an installer, if you're an installer or if you're a salesperson, you might be both oftentimes. So I think it's important to kind of understand, and really it all starts with how to choose the right project. When it comes to our access solution, I look at access as a great example to jump in when it comes to retrofit. So maybe a PV system that's already in place. It's a great opportunity to do that. You can keep your current rapid shutdown compliance typically. It's outdoor rated. Most of the components in your existing solar system are probably outdoor as well. You can add additional storage scalability. And we even have UL 9540 approved solutions. So that's really, I see the access as a big advantage when it comes to retrofit. So we're talking grid tied solutions that are already there, and we just want to add a battery into the system. We don't need to do that. We can always add in batteries and inverters, not as an all-in-one solution. We have the products for that. We've got Boss 6 and Boss 12. These are our battery cabinets that are also NEMA 3R rated. And they allow for a little bit more greater flexibility on scalability. But it does take a little bit more installation knowledge and practice to do it that way. Off-grid solutions, we warranty all of our products for both on-grid and off-grid, including our access units. So there's no, hey, you can't use our access off-grid, it's not warranted. You're absolutely okay to use our access off-grid. If you are using our access off-grid, though, please use DC coupled. AC coupled does not work well off-grid. I don't recommend it ever. You can always use our standard batteries or our SimpliPhi batteries. These are scalable and they can meet really any high power demands. So I believe here on the right is the Governor Brown's house, former governor of California, and pretty big house on the property and quite a bit of demand. So I've actually seen this site, and there's a lot of power being produced and being used off grid. The good news with our standard batteries is they're building blocks. We can build out as much as we need to or as little as we need to. And we still have the benefit of the CO recharging with any of our products, which allows for that quick, definitely if you're talking off grid, maybe you have a low solar production day, we can still utilize a lot of solar all at once. And if you've got a customer that maybe is a little savvy on the tech or smart home stuff, monitoring, I would definitely go with our SimpliPhi battery. This gives a little bit more granularity, as I mentioned, and can really kind of give that more intelligent side of things when it comes to monitoring. So we all know those customers. There's some that just can't keep their eyes off the monitoring system. In that case, I would use our SimpliPhi, either with putting it all together yourself, going with one of our access solutions, or even just the Boss cabinet with an outdoor rated solar. And even looking at, there's a little plug for some smart panel stuff that I've just been looking at a lot lately. They're definitely becoming more and more popular, but systems that are compatible with some smart panels as well, like Lumen NAC and Coben. So again, if you're looking at you got a techie customer, it's never a bad idea to look at the SimpliPhi battery, as they're going to have a little bit more granularity and some really accurate readings. All right, 2 more slides on the sales just to wrap it up. We have some tools that are really helpful for sales as well. Levelized cost of energy is really a tool that shows how to compare batteries beyond upfront costs. We're looking at the lifespan of the battery, and based on warranty, based on cycle life expectancies, efficiencies, all sorts of different characteristics. I won't click this calculator, but play around in it with a while, or play around with it if you have a chance. It is a really handy tool to maybe take another lithium battery that you're comparing to and show the customer exactly what the cost is of the entire battery over the lifespan of the battery, and not just that initial upfront cost, which, as always, we try to keep that cost coming down. But we also want to show that our batteries have a significant ROI, or return on investment. That tool is available on our website. It's really easy to use. And I believe they might have just linked it in the chat too. So, all right. And last, I'm going to mention on the sales side of things is financing, or as our other trainer, Matt Walker, likes to call it, financing with a PHI. I know it's clever. So if we're looking at financing, I would recommend going through LoanPal, and Soligent actually has some resources as well regarding LoanPal. So if you're familiar with them, you can use this for our batteries. The app's really handy. And I think it's kind of, as far as I've seen, it's very contractor friendly, and actually be able to offer that directly to the customer. So I'm definitely not an expert in our financing options, but I definitely think looking at LoanPal and seeing what even Soligent uses as well for it. So I would look into this. And really, the name of the game is financing is kind of key when it comes to bigger purchases these days. So being able to offer that to the customer is going to win you a lot more projects. All right, very last, a little plug on the IQ program. This is our installer qualification program. This is not a requirement to install our batteries. I'm going to say that again because I always get questions after every training. If it's a requirement, it is not a requirement to install our batteries. What it is, however, is a way to promote your own business as an installer that uses SimpliPhi batteries. So if you're already installing our batteries, you've got 2 installs done, just apply for the program. It takes 5 minutes to put the application through. You can end up not just on our where to buy page. So actually you'll show up as a little blip where customers will say, hey, I'm looking for an installer in my area to do my install. They go to our website all the time. We get tons of customer traffic. They'll see your company as somebody that's gone through this qualification process and taken the extra effort to actually show that they know exactly what they're doing with our batteries. Your distributors will probably also send leads to these people over others as well. And I know our company will if asked for a specific installer. So again, if you're already installing our batteries, if you already have 2 installs done, just go to that page, right under support, installer qualification program, apply for the program. Matthew or myself or another team member will get you fast tracked. We'll get you put up on this map. You'll get highlighted in our IQ newsletter. And even we're going to be doing some interviews on our most recent endeavor, which is our kind of little podcast we're running where we interview different people. We'll be interviewing some of our IQ installers on there as well to promote their businesses. All right. That is all I have for today.